Hello, this is my interactive concept presentation for Chem 2 at Doane University. Today we are going to be making elephant toothpaste. So I've already started this experiment by getting some hot water and yeast mixed together. I'm going to be using a water bottle for the container. So the first thing we're going to do is add some hydrogen peroxide into the bottle. About 10%. We're gonna go right about there. And I'm using 3% hydrogen peroxide. If you use stronger, the reaction will be stronger. So next thing, we need to add a little bit of soap in here. So I'm just gonna use some hand soap right here. You're just adding a couple drops. There we go. We'll swirl that together a little bit. Next thing we're gonna do, some handy dandy food coloring. Add a couple drops in there. You don't have to do it, but it makes it look cool. So, swirl that together a little bit. And then here comes the reaction, hopefully. If it doesn't work, we'll kind of talk about what went wrong, but oh yeah, look at that. Oh, look how cool. Important to note, don't touch it, it's hot. Wow, it's called elephant toothpaste because it does look like a big squeeze of toothpaste. So let's talk about this reaction that's happening right now. So obviously we added some hydrogen peroxide, which for those who don't know, it is H2O2. It's the chemical makeup of that. And then we added warm water and yeast, just dry yeast. I just used active dry. So you just add that with some warm water to get it activating, get it going, hand soap, and food coloring, and that's it. So what's happening is hydrogen peroxide, when it's broken down, it turns into H2O, water, and also O2. So we have oxygen being made. So this reaction can be kind of slow. So what we're doing is we're adding yeast into it, which has something called catalase. And this acts as a catalyst for the reaction of hydrogen peroxide. So instead of this being a long, slow process, we are then instead seeing it kind of amplify and speed up. So all those bubbles we saw at the beginning, that was the O2 being released out of there. Because it is a gas, O2, it's trying to escape the liquid. But what we did is we added in dish soap, well, in this case, hand soap. And all that's doing, it's not necessarily that it has some chemical reaction going on with it, but what it does is it adds enough surface tension that that O2 can't break out. So instead you just get a bunch of bubbles, kind of in this, you can still see it's kind of slowly still coming out, kind of this slow formation in a tube shape because it's all trapped in there. So, and the food coloring is just for fun, so. But that's essentially what's happening here. We're seeing hydrogen peroxide breaking down, but being sped up by the yeast. And the yeast, of course, is activated and sped up by the hot water. If we'd used cold water, it may have still worked, but probably would have been a lot slower and less effective than this. So when you're trying to speed it up, you want to add in something warm. And the reason I told you at the beginning, best not to touch it, is because while you do use hot water to activate the yeast, this is also an exothermic reaction. So we're still getting heat made from this reaction. So the hot water is there, but it's also heating up from hydrogen peroxide breaking down. So that's a little fun fact for you about the experiment. Not endothermic, it's not releasing it out, it's heating up right here, exothermic. So yeah, surface tension from the soap, quick activation of hydrogen peroxide leads us to elephant toothpaste. like I said, things that could have gone wrong. The yeast not being activated by the hot water, potentially also different levels of hydrogen peroxide, like I said at the beginning. It is kind of hard to find anything more than 3%, just because anything higher needs to be a little bit more regulated, especially with kids. So it's a little bit harder to find, but you could also make this a little bit more of a reaction by adding in some potassium iodine, but we did not do that today. And it looks like the reaction is pretty much done. So yeah, I hope you enjoyed this presentation on elephant toothpaste and why we get this reaction. It was certainly a fun one to do.